We are in Chapter 2, Section 1. Let's do Example 2-2. I want to start just above it where it says how are we going to construct this group frequency distribution. And I want to point out that first it says determine the classes. Find the highest and the lowest values. Find the range. Select the number of classes. And then find the width by dividing the range by the number of classes and rounding up. A whole lot of stuff, but if you look here at our list, it's talking about some raw data, high temperatures and degrees Fahrenheit, 50 states, construct a group frequency distribution for the data, use 7 classes. What we just read said, find the highest, the lowest, the range, and then we've got 7 classes, divide it and round up. And so off on the side, I've already calculated that our highest number is 134 and lowest is 100. When we subtract, which is the range, divide by 7, we get 4 9/10, and we round up and we get a class of 5. So, sorry, the number of classes, and then, hello, the number of classes is 7. The class width is going to be 5. So the bottom of the page talks about what we just did. Keep in mind we have a total of 50. That's really important when you go to double check on your homework or on the test, that the total number of data values is 50. We've got 7 classes and we want them to be a width of 5. From the earlier pieces and videos, you know that they have been drawing tables. And you have the tables here. And I'm going to go ahead and show the table down here. Cover up some of the pieces and parts like that. Well, then the frequency is still showing. So, class limits. Let's talk about those for just a second. We know that we have 7 classes and we're going to have a width of 5. I wanted to take a moment to look at this one, remind you that our minimum value is 100. And we have to make sure that we at least start with 100 or have it covered and go all the way up and at least end or cover 134. I'm going to start here with 100, which happens to be the minimum. The thing that I wanted to say is with a width of 5, I don't write down 105. I like to use my fingers. And to use my fingers, if I'm at 100, I'm going to go 100, 101, boy that's hard to see, 102, 103, 104. Do you see how I've used 5 values? 100, 101, 102, 103, 104. So my width is going to be a 100 to a 104. Even though you only see 4 values, the actual formula is to do 104 minus 100, then add 1. That's how you do it mathematically. But sometimes it helps to see, oh, it's 100, 101, 102, 103, 104. There are my 5 values. We can do multiple ways from here. We can do an adding, like 100 plus 105. 100 plus 5 gets us to 105. 104 plus 5 gets us to 109. But just to double check that, 104, next would be 105, 105, 106, 107, 108, 109. It checks. The boundaries, we've got to go down to the 10th. And going down to the 10th, we'll back down to 99.5, and we'll go up to 104.5. And we'll continue that process. Here would be 104.5 up to 109.5. Remember in an earlier video, the boundary says it starts here and it goes up to that 104.5 but does not include the 104.5. The next boundary will start with 104.5 and go up to 109.5 but will not include 109.5. The next thing we're to do after we have found the class limits and the class boundaries is to tally. And on the tally, a lot of times people just want to scan and count. Like, from 104 to 105, I'm just going to scan and count. And that's not accurate. That's not the best. The best is to look at all of your boundaries, actually that or your limits, and then as you're looking at your data, and it's really helpful if you have somebody to do this, have somebody call out 112. and then you go put 112 where it belongs with a tick mark. And then keep having someone call out, okay, 100, you put a tick mark where it goes. And then when you're doing the tick marks, you have 1, 2, 3, 4, and then when you get to 5, you cross over, and that makes it easier to count. 5, 10, 15, 16, 17, 18. You still may choose to scan, just be extremely careful. If we're doing 100 to 104, then you would scan and do 1, 1, etc. When we get over here, we notice that there are only 2. I just kept going on the 1, I didn't keep going. But after you do the tally, then you go to the frequency. The thing, and I've got my little note over here on turn sideways. I do want to go ahead and turn it sideways on the tally, and then I want to show you one more thing. But when you do turn it sideways, a cool thing happens. And if you're familiar with a normal curve, and we'll talk more about those, a normal curve starts to show up based on your tallies. And it's pretty cool, and we'll talk more about normal curve and its features later, but just kind of a neat thing to look at. But the word cumulative keeps coming up. And if it says cumulative frequency, that means you're going to accumulate, like snow accumulates. We're going to start with our 2. And the very first one I have 2. But to accumulate means 2 plus whatever's next. I'll write down the 10. Accumulate means I'm going to take my 18 and my 10 and get 28. And when I get done, by golly, I better have 50. And the same thing you could count over here. Adding all of these up, it better end up to be 50. That's a really fast way to double check to know if you've made a mistake on your tally. You could still get this right and still have the tally wrong, but it is a way to do a quick double check. There is a frequency. There's a sentence I want to read, and it says the frequency distribution shows, and all this is saying is it's just a way to interpret, because you may remember in an earlier video I said you're going to have to come up with ways to present, speak, write a couple of sentences on. And this is a really good sentence that you might want to look at. So at the bottom, the cumulative frequency. And so I've already shown you that. I showed you that there. So on the next page, I wanted to show you a few more pieces of information. One of those being a really cool piece of information and another good vocabulary word. After you have organized the raw data, it's going to be analyzed. You're going to look at different things like peaks, extremes, and then like when I turned it sideways and we saw the normal curve where there was a peak, that's going to tell you some information. But then extreme values are going to be called outliers. And they're going to show this large or small data values that are relative to the other values. So just jot that down, write down some information about it. When the range of the data values is relatively small, it can be constructed under what's called an ungrouped frequency distribution. We're not going to use that. I just think it's interesting to go ahead and point out. In your notes, I'm going to suggest that you do this next example by yourself, preferably with no notes at all. I will put something like this on the test, but I can't have this many data values. It's going to have about 20. That's it. But do practice, and do practice it by memory. Right here, when you're constructing, the guidelines presented should be followed, but yet you can construct different ones, different class, different values, different starting points. They can all be correct and all have different pieces inside of it. The data values will still be the same or accounted for the same, but how you represent them may be different. But you just need to follow the rules about having the same widths, etc. And we've already mentioned those a couple of times. I want to keep going. So down here at the bottom of the page are some reasons for constructing a frequency distribution. And at the bottom of this page, you notice that it says to organize the data in a meaningful, intelligible way. In other words, when we first started this chapter or this section, we were looking at numbers, and it's like, wow, that's just a whole bunch of numbers, and they don't really mean much. Like here are a whole bunch of letters. They don't mean much. They're not organized. And then here, a whole bunch of numbers. They're not organized. But as soon as you get them to a table, you can start talking about which ones are the highest, which ones are the lowest. Oh, look, it kind of looks like a normal curve. It gives you some order. Also, it's going to enable the reader to determine the nature or shape, which that's part of the order, and to facilitate computational procedures for measuring average and spread, and we'll talk more about those throughout our semester. And finally, to enable the researcher to draw charts and graphs for the presentation. You never know what job you're going to end up with where you need to use a presentation, and it's going to help you to decide which graph you want to use to illustrate what you're trying to show the best, and to enable the reader to make comparisons. Because as soon as you look over here, when you start looking at the frequencies, you can start to make some pretty quick comparisons, especially when one group has 18 and a couple of groups have 1. It's really helpful. It's a great process. But to finish up this chapter, I suggest that you get with some people in your house, or that you get with some of your classmates, and you work through, or maybe you do it by yourself, but you work through this Applying the Concepts 2.1. Remember, all of the answers are on page 114 on this one, and it's just really good practice to be able to do it without looking at your notes, and that's replicating a testing situation. So this finishes Chapter 2, Section 1.